This video covers two topics. One of them is the relationship between tangent segments that meet at a single point. All right, like this 9x is a tangent segment, and this 4x plus 30 is another tangent segment. The other concept is the fact that congruent arcs go with congruent chords. So if the arcs are congruent, the chords are congruent, and if the chords are congruent, the arcs are congruent. All right, now those concepts are so straightforward that this lesson is going to be very easy. Let's just be honest. In almost every case, it just boils down to one segment is equal to the other. So, for example, in this case, these two tangent segments will be congruent. So that means that 4x plus 30 must equal 9x. Okay? So I'm going to subtract 4x from both sides, and that's going to give me 30 is equal to 5x. Then I need to divide both sides by 5. And I get 6 is equal to x. All right, similarly for problem number 2, these two tangent segments, again, will be equal to each other. So that means that 8x minus 21 is going to equal 5x plus 15. I need to get these x's together, so I will subtract 5x from both sides. That's going to leave me with 3x minus 21 is equal to 15. Time to add 21 to both sides. So that leaves me with 3x is equal to 36. To get x by itself, of course, we will divide both sides by 3. And that will give me x is equal to 12. All right. This has some additional information, so we're supposed to find x and then also find the diameter of circle A. Well, the first part is going to be the same. So these two tangent segments are still going to be congruent to each other. So I can start off by setting these equal. So 6x minus 21 should equal 15. Very straightforward. So then I will add 21 to both sides, and then I get 6x is equal to 36. Time to divide both sides by 6. And I get x is equal to 6. Okay, now it's time to find the diameter. Well, let's start by knowing the radius. Okay, so the radius is right here. That's 2x. Since x is 6, that means 2 times 6. So that means that the radius is 12. If the radius is 12, then, the diameter is going to be double that. So the diameter then will be 24. All right, because the diameter is the whole thing from one side to the other. So that's 2 times the radius. Okay, again, the first thing we're going to do is set the two tangent segments that meet equal to each other, because they have to be congruent. So that means that 7x minus 5 is going to equal 5x plus 1. Subtracting 5x from both sides, we have 2x minus 5 is equal to 1. Then we will add 5 to both sides, and that gives 2x is equal to 6. Then we would divide both sides by 2. And we have x is equal to 3. All right, fine. Now we're supposed to find the length of TS. Well, TS is right here. TS is 5x plus 1. So this will become, since x is 3, that means I have 5 times 3 plus 1, which of course is 15 plus 1, which is 16. So TS is going to be 16. Oh, there's more. Okay, now we're supposed to find SR. Okay, well, SR is down here. This is at, I feel like I should change colors now. This is SR. Okay, so that's going to be, again, x is 3, so that means 3 times 3 plus 3. So that's 9 plus 3, so that is 12. So SR is 12. Okay. So now we are supposed to find RT. Okay, let me switch colors again. So here's RT, and that's what we're supposed to find next. I'm going to call this, let's see, I can't call it X because we've already used the variable X. I'll call it Y. Okay, I need to find Y. Well, guys, focus your eyes on the following triangle. All right, I have this triangle right here. Triangle TSR. There's a theorem that tells us that the radius is always perpendicular to the tangent. So that means this is a right angle, which means what I have now is a right triangle. Okay, now on this right triangle, I know that one side is 16, one leg is 16, and the other leg is 12. So I have 2 legs, and I'm trying to find the hypotenuse. Well, this looks like a job for the Pythagorean theorem. Okay, a squared plus b squared equals c squared. Leg squared plus leg squared equals hypotenuse squared. Okay, so in this case that means 16 squared plus 12 squared is equal to the hypotenuse squared. All right, let's get some calculator action in here. All right, so you know what? 16 squared plus 12 squared. Let's cut to the chase. That's 400. So 400 is equal to the hypotenuse squared. So if I want to find what the hypotenuse is, I need to take the square root of both sides. And that's just going to be 20. All right, so the hypotenuse is 20, so that is the length of RT. Okay. So again, if the arcs are congruent, then the chords are congruent. So since arc DE is congruent to arc BC, then guess what? Chord DE is going to be congruent to chord BC. So that means, once again, I can set these equal to each other. So 10x plus 3 will simply equal 2x plus 55. Easy peasy lemon squeezy. And then we will subtract 2x from both sides, and that gives us 8x plus 3 is equal to 55. Subtracting 3 from both sides gives us 8x is equal to 52. Time to divide by 8. And we get 6.5. Once again, if the chords are congruent, then the arcs are congruent. So that means that 11x minus 9 will equal 8x plus 21. Subtracting 8x from both sides leaves us with 3x minus 9 is equal to 21. Adding 9 to both sides, we have 3x is equal to 30. And then you divide both sides by 3. And x is equal to 10. But we don't stop there. Oh no. We move along. The measure of arc DC. Well, here is arc DC right here. So that is a 11x minus 9. Okay, so that means, so the measure of arc DC is going to be 11 times 10 minus 9. All right, 11x minus 9, I'm substituting in 10. That's going to be 110 minus 9, which is 101. But it doesn't stop there. Oh no, now we're supposed to find the measure of arc CB. Well, we already know that these are congruent, so it would be silly to plug 10 in for x when I can just say, oh, that will also be 101. They're congruent. Now, how about the measure of arc BD? Okay, well, arc BD is this arc right here. All right, so we already found that this is 101 and this is 101. And now we're asking for this third part. Well, together these make the full circle. So that's why I should be able to simply subtract from 360. And that leaves 158. Okay, now the measure of angle C, what's up? Well, look at the pizza slice that is created if I highlight this angle right here. Okay, so notice that the vertex is on the circle. And we learned the relationship that when the vertex is on the circle, then the angle is half the arc. The arc is double the angle. So if I just divide by 2, that's going to give me the angle. So that's going to be 79. Okay, So it's going to start off as more of the same. These arcs are going to be congruent. So that means that 12x is going to equal the 9x plus 24. Subtracting 9x from both sides, it's going to leave me with 3x is equal to 24. But then we would divide both sides by 3. And we have x is equal to 8. So far, so good. Now they want the measure of arc ED. Arc ED is here. All right, so that 9x plus 24 becomes 9 times 8 plus 24. That is 96. All right, what's next? Measure of arc BC. Well, the measure of arc BC, that's the arc that we know to be congruent to arc ED. So if arc ED is 96, then that means arc BC is also going to be 96. Okay, now what about the measure of angle A? Okay, well, where's the pizza slice? Here's the pizza slice. Boom, look at this. Notice where the vertex is. The vertex is at the center of the circle. And we have learned that when the vertex is at the center, the angle and the arc are the same. So we just said that the arc is 96 degrees. So if the arc is 96 degrees, guess what? The angle at the center will also be 96 degrees. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.